Okay, so I just we're gonna recap really quickly what we did Friday. We started this on Friday. Okay, so absolute value inequalities. We discovered that if we have an absolute value that's less than, it's an and if we have an absolute value that's any kind of greater than, it's an or, right? Okay, and then we kind of went through some basic ones, right, where all the algebra is the same as the equations. Okay, we realized, okay, so we left off with the example where we had to isolate the absolute value first, and then split positive and negative half. All right, and we did, this was the last one we did, right, number 4? Perfect, good. All right, so we're going to keep that going with number 5, okay? So just like that number 4 that we left off with, we could not split and we could not decide what kind of inequality we had until your absolute value is isolated. You don't split, you don't decide what you have until that happens, okay? You cannot distribute over absolute value, okay? So how do we get rid of that -2? Well, you gotta ask yourself, what is that -2 doing to the absolute value? It's being multiplied, right? So we'll want to divide. Okay, so we're dividing by a negative right off the bat. So what do we gotta notice here? If I'm dividing by a negative with inequalities, that symbol is going to switch. That right there is why we can't decide if we have an and or until we have our absolute value isolated. So absolute value of x plus 4 is not greater than or equal to, but less than or equal to 12 divided by -2, which is -6. Oh, anybody's spidey sense is going off. Yeah. Well, absolute value can't equal a negative, and it certainly can't be less than a negative, right? Okay. So, yeah, I mean, logically, you can look at that and go, well, there's no solution, okay? And great. But let's look at why. Yeah, the answer is no solution. Let's look at why. What if you, because you know, I'm teaching it to you, you're like, you're here, your brain is in it, but if you're doing a bunch of these for homework, you might not remember that, right? You might go, all right, I'm going to split. And you can split. Oh, would this be an and or an or? Less than, it's an and. Okay? So that right there tells me, okay, so this is and. So I would have x plus 4 is less than or equal to -6. And this guy, negative x plus 4 is less than or equal to -6. Okay, and math is going to let us keep going. It's going to let us go. So I have x is less than or equal to -10 over here. Distribute my negative on the right side. Negative x minus 4 is less than or equal to -6. Then we'd add 4. Negative x is less than or equal to -2. Bless you. And then we divide by -1, and oh, sign flip. I'm dividing by a negative. So I have x is not less than or equal to, but greater than or equal to a +2. Okay, so if I state this is work, right? But then I would state my compound inequality. My compound inequality is x is less than or equal to -10, and x is greater than or equal to 2. That's the compound inequality. If I try to make a little practice graph, okay, so -10, close circle, going to the left, 2, close circle, going to the right, and this is an and, it's an and, So there's no overlap, right? There's no overlap. So then it's no solution. So what does your number line look like? Blank. Okay? Just, if it's on the page, you just don't color anything in at all. And the solution would be no solution. You say that with a null set or with an empty set. Okay? So, if you can logic at the very beginning and know, oh, absolute value can't be negative, so it certainly can't be less negative, right? You could stop there and say no solution, and that's okay. That would be sufficient work. Or you can continue as long as you recognize, oh, yeah, this does have no solution, okay? So if this was your problem, it would be okay to notice that and not do the work, is what I'm saying. All right. I'm sorry. Any more questions about this one before we do the next one? Okay. Let's look at this guy. Okay. Absolute value of x plus 5 plus 7 is greater than 4. Again, we got to isolate the absolute value, right? So we have to remove that 7, which is being added to the absolute value, so we'd subtract it. So I have absolute value of x plus 5 is greater than 4 minus 7 is negative 3. Okay. Can absolute value be greater than a negative? Yeah. I mean, positives are greater, right? So I can keep going with this one, okay? But it's a greater than, so that means it's and or? Or, more or. So that one's going to be an or, okay? So we can split and we can solve. So we've got our positive path and our negative path. Our positive path would be x plus 5 is greater than negative 3. Or our negative path is negative that x plus 5, oh well, I'm trying to color code, is greater than negative 3. Okay, and then we can solve. So we can, over here we can minus 5, so x is greater than negative 8. Here we can distribute the negative, so negative x minus 5 is greater than negative 3. So we can add 5. So negative x is greater than 2. Divide by negative 1. Oh, look, there's my sign flip. Dividing by a negative. So x is not greater, but less than negative 2. Okay, so now I have to state the compound inequality, which is x is greater than negative 8, or x is less than negative 2. And let me practice graph this one. Greater than negative 8, open circle, going to the right. Less than negative 2, open circle, going to the left. And it's or, so numbers get invited to the solution set as long as they satisfy at least one of these. So what numbers are invited to the solution set? Numbers greater than negative 8 and also numbers less than negative 2. Wouldn't that just be all the numbers? The whole number line, right? Because they don't, I'm not looking at the overlap. It's just both of these put together. So it's really, I mean, you can mark these numbers on the number line if you want to, but the solution set is the entire number line. The entire number line is the solution. So you can say that with a double stemmed R for all real numbers, or you can say that in interval notation. It goes from negative infinity to positive infinity. Okay. I want to show you this one graphically for a second. This is just, so if I graph this side, x plus 5, and then plus 7, and then here I have y equals 4. Okay, and the problem says, when is the left side greater than 4? So when is our absolute value function greater than 4? Well, for all values of x, right? Forever, this function is above 4. So that's why it's all real numbers. Okay? Cool? Cool? All right. So these were the special cases that I just wanted to show you before you hit your worksheet 5. All right, now more of these guys. These are just like those word problems. Writing, so this is kind of a backwards question. It says, write the following compound inequalities as an absolute value inequality. So it's giving me the compound. I want to go back to writing it like this with absolute values. Okay? All right. Here's how you do these. Okay? First of all, map it on a number line. So take this guy, put him on a number line. Okay? Figure out what it is we're looking at. Okay? So, I'm going to do a little number line. This is saying x is in between, right? -2 and +8, inclusive, because we have equal to bars. Okay, so it's all the space in between here. Okay? Okay, if we want to go back to being absolute value, remember, absolute value is a distance, okay? Always remember, absolute value is a distance. So what my number line is saying, it's saying the distance of something is in between 8 and 2. So we got to figure out, well, distance between what? We need to figure out where's the middle of this. So we need to determine the midpoint. What is right in the middle between -2 and 8? Well, remember midpoint from geometry? Add them, divide by 2. So I need to find the midpoint between my two endpoints, the midpoint. So I would take -2 plus 8, and I would divide it by 2. So -2 plus 8 is 6. And 6 divided by 2 is 3. So that means the middle is 3. I need to know the middle because now I can figure out, well, how much distance is in between our midpoint and both of these endpoints. So now I got to figure out, well, what's the space in between? How many units is in between these? It's 5, right? There's 5 units on this side and 5 units on that side. So the absolute value, which is the distance, is 5 or less, right? Because the shading is in between, so these represent the farthest it could be or less. So I know absolute value of something is less than or equal to 5. I just got to figure out what goes in this something, right? Okay, well, that's why we got to know the midpoint. So the difference between x and 3, is less than or equal to 5. Think the difference between whatever x is and 3 is less than or equal to 5. Or view this like it's the absolute value function shifted to the right 3, right? Because normally absolute value is a distance from 0, right? But if we move this to the right 3, now that's the middle. And what does right 3 look like in a function? It looks like minus, okay? All right, so you want to map it on a number line first, okay? Figure out your midpoint, and then figure out how much is on either side, okay? Y'all want to try, well, yeah, go ahead, try this one. It's the exact same scenario. So you want to map it on a number line, find the midpoint, and then figure out how much space is on either side of that midpoint. okay? Okay, so we all able to map it and figure out that the middle is 320? Cool. All right, now the thing is, you gotta figure out, well, how much is on either side? 80. Okay, so there's 80 on either side, okay? So our absolute value, so the difference between S, because that's the variable, right? And our middle, which is 320, so S minus 320, greater than or equal to, or less than or equal to? So these are, if it's an in, it's less than, because this is and, right? So less than or equal to 80. How would you know it's greater than? If these were pointing outwards. If they were pointing outwards, the only difference there, you do it the same way. If they were pointing outwards, your symbol would just be greater instead of less.
How would they be pointing outwards?
Good question. Let's say that the compound inequality, new question, let's just say that the problem itself was S is less than or equal to 240, or S is greater than or equal to 400. So this would be the way the problem was delivered to me, okay? So I'd be like, okay, let me map that. Okay, so I got 240, I have 400, less than or equal to, this way, or greater than or equal to 400, this way. But I still need to find the midpoint. It's just that the distance that S is between, the difference between the distance of where it is and 320 is this amount, which is 80, right? It's 80 or greater, because it's farther away from the middle. So this would be saying the difference between S and 320 would be greater than or equal to 80, because it's farther away. Here's where 80 is, 80 units or more, so it'd be greater than or equal to. Okay? But normally in these situations, they're like a word problem, they'd be less than, because again, it's like a margin of error situation. Okay? Okie dokie. Stop.